Welcome to Function Transformations Part 1, Discovery. The best way to use this video is to take notes while I'm teaching. Pause the video often to get your notes down, and every time we arrive at a U-try, pause and attempt the problems. The solutions will be shown along with the work. In this section, we'll cover the following items. We will be using Desmos, so type in your browser desmos.com and then click the Start Graphing button to get to the graphing screen. Example 1. Using desmos.com, graph the parent function, so type this in. Feel free to type in y equals x to the second power, and then leave that in your first one, and then go ahead and graph all three of these below. Graphing them one at a time, sketching the graph, and let's note any similarities. Pause the video and press play when you're ready to see my answers. Alright, so when we graph these in Desmos, the red graph here is our parent function. So let's take a look at the vertex, and let's notice how the vertex moves. So when we have the parent function x squared and we subtract 2, it looks like the vertex moves down 2. When we subtract 6 from the function, the vertex moves down to 6, and we subtract 1, the vertex moves down to 1. Let's take a look at that with a different parent function. Go ahead and type that into Desmos, and then type these in. First, make a prediction. Now we're adding 2, we're adding 6, we're adding 1. What do you think is going to happen? Press play once you've graphed those in Desmos. And we get this. So here our square root function begins at the origin, and when we add 2 to the function, it moves up 2. Starting at 0, when we add 6, it moves up 6. Starting at 0, it moves up 1 when we add 1. So, what happens when we have a function and we subtract a value? It moves down a. And when we add a constant, it moves up a. You try these examples without graphing, just using the equations to determine what happens to the parent function. And these are the solutions. All right, we're going to go back into Desmos, graph the parent function, f of x equals absolute value of x. Now these are going to get a little bit tricky, so go ahead and graph these three functions into Desmos. Note any similarities, differences, and we're going to use the words vertical stretch and vertical shrink. When we talk about a vertical stretch, we're talking about pulling the parent function up and down. And when we talk about a vertical shrink, we're thinking about pushing the parent function up and down. Press play once you've got those graphed in Desmos. All right, so when we've got this function here, our red function is our parent function, and this graph has been vertically stretched to make it more narrow. So this is a vertical stretch. Here, our parent function is in red, and this has been vertically shrunk to look wider. This is a vertical shrink. Our red graph is our parent function. Our orange graph has been vertically pulled, so this is a vertical stretch. It looks more narrow. So let's take a look. When we have a number that's bigger than 1, we get a vertical stretch on the outside of our parent function. And when we get a number that's between 0 and 1, on the outside of our parent function, we get a vertical shrink. So again, when we have a number outside of the function multiplying, it's bigger than 1, we get a vertical stretch. And when we've got a number multiplying the parent function and it's between 0 and 1, we get a vertical shrink. You try the next examples without graphing. Press play when you're ready to see the solutions. Moving right along, we've got the parent function x squared, or the quadratic. Graph that parent function and graph this function below it. Notice what happens. Then graph this parent function and graph this. Notice what happens. Press play when you've got those graphed in Desmos. All right, so our red parent function is going up And then when we put in our negative x squared, it goes down. Our red parent function is here. And then when we type in the negative, it's down here. These are reflecting over the x-axis, if you were to fold it in half over the x-axis. So what happens when we have a negative multiplying the outside? It reflects over the x-axis. Without graphing, describe what happens to these parent functions. How'd you do? All right, next up, we're going to be looking at the rational function. So go ahead and graph the rational function in Desmos, and then graph these three functions below them. Note any similarities. See if you can watch that asymptote move. Press play when you've got them in Desmos. And let's take a look. So the parent function is here in red. What I want you to kind of keep track of is maybe one point. Maybe you grab this kind of point here and we'll watch it move. So this point moves over here. All right, and then let's think, okay, we have this -3. It looks like it moved in this direction. It moved to the right 3. Let's take a look at this guy here. Looks like he moved right there to the right 1. We have a -6 happening to the x itself. We have our red function here moving in this direction all the way over there. It moved to the right 6. So notice they're all moving to the right when we subtract inside the function or to the x itself. Let's take a look at another example. Graph the parent function square root and graph these in Desmos as well. Note any similarities. Now we're adding on the inside of the function. Maybe predict and press play when you've got your Desmos up. All right, so our square root function starts at that origin. Let's watch this point move. It's moving to the left 2, and we're adding 2 on the inside. Here's our starting point. It ends up over there. We're moving to the left 4, and we're adding 4 on the inside. We've got +5. It moves to the left 5. So how can we summarize this? Well, when we subtract on the inside, we would think subtract means left. That's a common mistake, but it actually moves to the right A. And if we add, it moves to the left A. Without graphing, give these a try. Notice that a few of these have more than one transformation. See if you can recall what we've already learned. How'd you do? All right, let's keep moving along. We've got the parent function f of x equals x squared. We're going to graph these functions in our graph, in our Desmos, and we're going to use the words horizontal stretch and horizontal shrink. A horizontal stretch, we'll start with shrink. A horizontal shrink means it's pushing in horizontally. It's going to end up becoming more narrow. And a horizontal stretch means we're going to be pulling it out. It's going to end up getting wider. Press play when you've got those graphs up on Desmos. All right, let's take a look here. So our parent function is in red, and this graph is being horizontally pushed in. This is a horizontal shrink. Now you need to make sure you use the word horizontal. Don't just write the word shrink because we've got vertical shrinks, and this is actually a vertical stretch. So we've got our red function. This is horizontally pushing out. It is a horizontal stretch. And here it's gotten much wider. This is also a horizontal stretch. So again, you can't just write the word stretch because we have the word vertical. So let's take a look at the equation itself. So we're multiplying, but this time we're multiplying on the inside. This number is bigger than 1, so we end up with a horizontal shrink. We've got a number multiplying on the inside, so that's horizontal. It's less than 1, so it's a stretch. So when we multiply on the inside and it's bigger than 1, we get a horizontal shrink. And when we're multiplying on the inside and it's between 0 and 1, we get a horizontal stretch. Without graphing, see if you can determine what is happening to these functions. Press play when you're ready to see the solutions. How'd you do? All right, let's keep moving along. We are going to graph the parent function, rational function 1 over x, and below it graph this transformation 1 over negative x, and then graph the square root function and the square root of negative x. All right, let's take a look here. Our parent function is in red, and notice that it shifted, it reflected over this y-axis. This guy went over there, this guy went over there. Let's take a look at the square root function. It also reflected over the y-axis, folding over in this direction. So when we've got a negative multiplying on the inside of the function, or to our x, it reflects over the y-axis. And our last U-try, we have a couple transformations in here without graphing. See if you can determine what those equations mean. And see how you did. That concludes part 1. Part 2 will be summarizing all the transformations.